Good afternoon, all. Uh, so we'll get started this session. Hopefully, people from Link and over the session they can join. So before I get started with this session, basically this particular topic. So to introduce myself, I'm Udayakumar. I work for Toyota Telematics GOC, and actually I have almost close to 15 years of experience, and I'm into the cloud for the past 4.5 years, and explicitly actually into analytics actually, for the last 2 years or so. And that's all about me. And I have been also a Microsoft certified professional for cloud. And in fact, I'm producing for the MCTS, the fully complete track actually, right? So to get started, guys, over the link, hope you're able to hear me.
Yes, we are able to.
Yeah, Uday.
Okay. All right. So to get started with this, so what I'm going to do in the next 2 hours is primarily to do a knowledge transfer. It's more of to do a knowledge transfer of what kind of an experience I had with Azure Machine Learning Studio, especially because we are going to focus on Azure Machine Learning Studio mainly, and what basically how it's going to help when we are into the kind of an verge now where more of the people are focusing on data scientists, and data science process, and also involves, where most of the industries and organizations and business are looking for, basically to do the predictive analysis mainly. So we are going to, just discuss on that front and mainly on the predictive analysis part of it, and I'm going to give an overall view, of course, with a demo. Most of the I don't have much to run with the deck actually, but just I will give you some basic information about to understand, how this machine learning is all about and what is the preliminary things which is we need to have in hands-on before we start doing actually any machine learning, and then get into predictive analysis solutions, actually building predictive analysis solutions. Of course, I'm not going to just quickly. Probably I'll have a quick run through to understand the kind of variety of people which we have right now here in this session training room right now here, and also over the link call now. Probably you can just raise your hands if I ask, and probably link you can just tell me who are all is having experience already, to understand about basically Azure first of all, and before getting into the machine learning part of it. So first of all, from this room, how many of you are having experience with Azure? Okay. So from the link, so guys, how many of you are already working with Azure, and how many of you are comfortable with Azure? I know a few folks from my team, so definitely they are into Azure. But apart from that, guys who are working on Azure, or maybe who's already at least trained on Azure, understands about Azure. Okay, I get some responses. Okay. All right. So I mean, I would. So in this case, I probably I have some at least a 95%. People say that they are new to Azure, right? And of course, this session is not to talk about Azure, right? But I'm going to just give a very quick overview so that it's easy to understand when I just mention some particular topics, or maybe a particular terminologies. It's easy to understand what I'm just trying to say over the session. So first to start with, as we all know, the world is moving towards a different kind of strategy where they wanted to keep everything on the cloud, and it's basically we talk about right from a quite long time. It's the cloud computing model actually. So we have under a cloud computing model we have varieties of different cloud service models, which includes actually the IaaS and PaaS, and SaaS. Which usually, if you take a SaaS is something which we are known for quite long time. Probably for example, if you take a very simple Salesforce is a great example for a SaaS essentially, right? And same thing, right now you can see so many of the services are getting offered. The software as a service is getting offered actually over a cloud, to make your business to quickly build up and make sure the service has been available cloud, and I don't get into any licensing issue. More of I go for a subscription kind of a model. So it's I'm going to invest more my time actually over on the kind of solution which I want to build rather for focusing on my IT infrastructure actually, right? So that's the main objective when I talk about an SaaS model actually. And when I come to an IaaS based model, actually, it's all about build an infrastructure itself over the cloud, so that I can actually have rather a mission which is more access like at my end basically, just acts like a monitor which helps me to just to connect to a remote machine, and then have all the configurations according to what I need actually. So if, for example, for any small startups or SMEs, they wanted to bring out their business, it's a matter of time nowadays. It's just to go ahead and and build your infrastructure on the cloud and roll out to your business. I don't need to have so many backups of so many investments across to be done on my IT infrastructure. Rather, I have to go ahead and always look out for some cloud service, a very good cloud service provider. I know some of you most would have already been part of some of the cloud service providers. Like for example, it could be an Amazon, or it's a Google, or right now with Microsoft Azure, and of course there are some other cloud service providers. So these three are the big time players in the market right now. So like this, Azure is something from Microsoft, which mainly to focus on all these services. So as I mentioned about the IaaS side, they also provide infrastructure as a service. So say, for example, if I need a Linux server up and running, so all I need to do is just go ahead and subscribe for a subscription actually with Azure, Microsoft Azure, and then get the subscription. Once I get the subscription, it's just a matter of time to go ahead and build a virtual machine which I can have whatever the kind of operating system which I require. Currently, Microsoft supports actually the Linux and the Windows and the varieties of different operating systems which are available right now. So that gives me to focus on my my other business part of it, which is really not my bread and butter, to focus on the IT infrastructure actually, right? And moreover, spending a lot of money on IT infrastructure is nowadays a big headache for every organization, and they need actually a very big infotech team behind the scenes to manage your infrastructure in place. As we know how much as an Harman guys, we know how much we are whenever actually any issues are there, how we are tracking it with actually the IT infrastructure to raise an incident and close that. But instead of that, now Microsoft is going to take care of everything, and I'm just going to manage that. But in case of IT infrastructure, it's like instead of you have the physical machine in your place, you're just going to have it in your remote location. But the thing is that it's still going to have you management to be done from your side actually. The only thing that you're not investing right immediately, you're not investing anything with you, which are going to be now some of the data location, and you're going to consume that the virtual machines which are over there actually, right? But when I come to the but this requires your complete management from your side. So right from operating system, the kernel, and then the overall application layer. So all those things has to be managed from your side. For example, tomorrow there is you have opted for a Windows Server 2000. And you want to go for a Windows update, you are responsible to go and do the Windows update on your own, right? You have to make the decision on your what. Guys, go ahead and mute actually if you're not. Please, all of you. I need to put. I think I have to put them on mute. Just give me a second. I'm going to put all of you on the mute. Someone is unmuted. All right. So that's the from the IaaS perspective. When I come to the PaaS perspective, it's a semi-management model. So it's a platform as a service actually. So all you need to do, you don't need to develop your solution and go ahead and deploy it. So it's like you have a service in place, a cloud service in place. You will have a for example, you built a web application and you want to deploy that actually, So all you need to do is build your web application and just say what kind of configuration this application needs to run in. For example, it requires actually to run in a A3 machine with actually, a 4-core processor with a 8 GB RAM and, and so hard disk actually specification. Then all you need to do is just set the configuration and, deploy your solution. So in this case, Microsoft is going to manage the infrastructure. The Microsoft is going to manage the virtual machines and everything, updates and everything. All you need to manage actually is on your solution which you are going to deploy, and also to get any updates on the deployments and everything. So that's going to give me a semi-management model of platform services. most of the solutions which people nowadays which used to build, they focus on developing on PaaS-based application, because it's a platform as services gives you that kind of scalability. It gives you, very reduced cost of management, and also moreover, it gives you a very rapidly building your solutions and going to the cloud and offering that as a service across to your providers or to your customers actually. So that is what these are the three different cloud service models, and these three cloud service models are something which is actually provided by a cloud service provider, and Microsoft is one of them, and Microsoft Azure is nothing but actually one of that cloud service provider who can actually offer you all these services, and Microsoft offers all these three services, right? So
Outlook 365 comes under which?
Yes, it comes under the SaaS. Yes, right. So we have mainly to focus here is actually on the Azure part of it, mainly on the machine learning studio. So when I come to Azure, as I mentioned, there are varieties of different sort of artifacts which are available as part of the Azure services, right? And which includes, like, for example, if I want to create a VM virtual machine which is required for my infrastructure, or if you want to create a cloud service. So when I create a cloud service, I can create a cloud service which will be three different roles into it. One is it could be a web role, it could be a worker role, or it could be a VM role. Web role is nothing but the infrastructure as a service which I mentioned. When I come to the web role and the worker role is something which is nothing but you build actually a web application, you build a web service, so then you can actually build it as a web role, which is basically called as a web role, right? And when it says worker role is something nothing but you are like typically you're building a service or a background job or which needs to run on the background. So it's basically you used to build a Windows service actually to run something on the background, right? So in that case, we consider that as a worker role. So cloud services which offers you these three different types of roles. And I can build it as a web role, or for example, if you're building a web application and you want to build it as a web role, so you can build it as a web role. And in the background, you want to do some data processing actually. So whenever there is a data comes in the asynchronous tasks you want to perform with a scheduler or a job, you want to perform something, then you can build it as a worker role. And you can go ahead to the cloud and deploy them. So the worker role is going to actually run on the background, and web role is going to run on the front. Web role is nothing but more of the presentation layer part of it. So that is one of the artifact actually. And apart from that, a cloud offers varieties of different services. It's not only about limiting with offering a virtual machine or offering an ability to deploy your web applications, or even, for example, if you are building a website and you want to run that in the cloud. Actually, nowadays we can even do a lift and shift model. So far you would have running in an on-premises server, and you want to push it to your cloud actually. So all you do is you can just lift and shift your simple ASP.NET website or maybe a Java application. Just move it to the cloud actually, right? With just doing a lift and shift model, where Azure provides something called actually app service. So you can use the Azure app service actually to lift and shift your websites as well actually, right? So that's one of the other one service model which you got. And Azure also provides something called service buses as well. Service, if you want to build actually service bus model, then you can use the service bus as one of the feature which is actually available as part of the cloud. And Azure also provides queues. Azure provides notification hubs. For example, you are building a mobile application. So when I build a mobile application, I just want to notify my mobile about So you get in your mobile actually with a notification in your notification panel. So when you get a WhatsApp message, actually the first thing you get is in the notification panel about the message, 2 messages received, right? So that is actually the notification push. So the notification hub can be built actually is actually part of the Azure itself. So like that, there are varieties of services as our cloud offers all these services. One of the services is basically the machine learning. So machine learning, and there is mainly when you are focused on business analytics perspective. So if you want to build business analytics solutions, so there are it offers you basically have a big data with you. Like even Microsoft supports actually the big data wherein actually we have something called HD Insights actually, Azure HD Insights actually. So you have the data with you. Now you need to do the analytics. So Microsoft Azure offers you something called stream analytics. So we can use stream analytics and machine learning. So for example, when we in this mainly for this today's session, we are going to focus on the machine learning part of it. So what machine learning is overall? So when I'm building an overall solution, like it could be a desktop app, or it could be a mobile app, or it could be any other type of enterprise app actually. I just want to do some predictive analysis solution. Because nowadays people are more interested on predictive analysis, right? I want to focus actually how my business will run actually, in another 4, 5 years, what will be my, or I want to see the trend actually. There are varieties of, predictive analysis people want to run. It could be even, for example, a very simple thing, is actually probably I just want to see, forecast and see, what other flights are going to be delayed because of the weather, right? Or it could be a traffic congestion actually. Or it could be, for example, actually the cancer rate which is going to be across India. So I want to do a predictive, or if I'm running an industry or a business, I just want to predict actually how how much will be my productivity, in another 1 year actually. So I want to predict that and accordingly plan myself and prepare and be ready to face any kind of situation. Yeah. So it's more of, to understand where I'm just, how do I need to prepare myself and keep my business keep going. So it's very important to have this predictive analysis in place. So with that note, so I mentioned this about this particular point, where about the machine learning. So Azure machine learning is a powerful cloud-based predictive analysis service, right? So it allows you, Azure machine learning gives you the capability to build actually a predictive analysis, and it's also gives you the capability to create and deploy the models. So probably when I say predictive analysis, the very important part of my predictive analysis actually is the input for me for the predictive analysis, the model. I need to build a model, right? So model is something which you have a, let's say if you have a, it's a model like, for example, if you're thinking about a flight delay prediction, so then probably you need a flight data. You need actually, what is the supporting data needed for that? It's like a weather, depends on the weather, actually it's going to be the weather, the flight is going to be delayed. So you have a two set of models is required. One is a flight and another one is the weather data. So this weather data, two things are the models which I'm going to use actually to perform my predictive analysis, right? So machine learning is something which is going to review initially the data. You can input a data, create a model, and out of the model you can create a predictive analysis. So but for how does machine learning can perform that is something always that comes under the data science part of it, right? So data science is all about to first to understand this part of it, right? You have a data with you which based on the because any predictive analysis is based on a data only, which is a past data, right? The past data is the input for you actually for the predictive analysis purpose. So you have a data in place, then you have to build a model on that. So when you are having a model, you need to also understand whether the data which you got, before getting even to create a model, first things you need to understand is whether the data is sufficient enough for me, or whether the data is in a form which I can actually use it for preparing my model. Because I would have definitely thought about some predictive analysis solution, right? Even when we build the solutions for our customers as well, the way how it works is, when we run across in a sprint doing a development of a predictive analysis solution. So the way how we go ahead and execute is we'll understand actually what is exactly the predictive analysis outcome for the business, right? For example, if it's for an hospital, or it's for a apparel industry, or it's for any kind of an industry actually. So we run through a predictive analysis and understand whether that is suits for their business. So the management will look for actually a kind of dashboard where they can see the dashboard report where what is going to be my business model, how I need to execute my, for example, if I want to, let's say for Myntra or for Flipkart, they are all, they want people like nowadays actually, they hire people like, just like, anything like for, if you are a data scientist actually, right? And if you know predictive analysis, because that's something, that's something that keeps running their business. Right? If Myntra, wants to do an, logistics actually, for next, for next 2 to 3 weeks, they need to predict that. Okay, my business is going to run, for example, it's going to be a kids wear, or it could be a ladies wear, or it could be a men's wear. So which one is going to be the more trend for the next 2 to 3 weeks? How can I change my, my trend so that people will involve, in getting into buying those products actually. So I need to come up with some strategy in place to plan for all those things, right? So, but the data which I have earlier may not be all very, very clean data for me to actually perform this. So what I have to do is, first of all, I have to pre-process the data. So after I receive the data, into machine learning, I cannot directly give it to machine learning and say, hey, please give me a predictive analysis. It has to be first pre-processed. The data has to be pre-processed. So pre-process is a process which has several things into it. There are several stages. In fact, it's a development, it's a life cycle into it. So it goes into a process where it could be a simple thing. For example, you have a data, for example, about cancer rates. Okay, so you want to predict actually, okay, whether men will get into cancer more or women will get into cancer more, and if they are going to get into cancer, what kind of cancer is going to get. So all these things, if I want to predict, I have a cancer data with me, the past cancer data with me, which is one sufficient data, and another one is I need to find out actually about the other reasons which will cause the cancer. So that is another one is supportive data which I require. So these data, when I take it, it may not be, for example, some data may be missing, some data may not be in appropriate format. So then what I have to do is I have to pre-process it by scrubbing the data. So basically I have to scrub it and clean that. And probably if I need, I need to split it also. Probably I would have a millions of records with me. I don't want to take all the millions of records. I want to do a sampling. I'll take a sample and out of that actually I want to predict as well. So for this, I can actually, first I have to do is pre-processing part of it. Once I do the pre-processing, then I get into the model creation. So I will create a model. What are the columns I need to focus on? For example, if it's a flight delay more predictions I need to do, predictive analysis which I need to do. So the data which I require is in the past flight data. Actually, I have to check the actual flight data's arrival time, departure time, and then in the same order I need to take the weather forecasting data as well. Then this data needs to be clubbed together, right? Then only I can able to create a predictive analysis based on that, so that in which airport what is going to be the flight delays. So this I can calculate. So that this all will be done as part of the model. And when you are preparing a model and deploying a model also, there are various processes involved into it, right? Which involves, for example, you create a model, then you have to train a model. So training a model is actually you saying, okay, these are the columns I need from this set of data. So you might be having a data from a web, because in machine learning, it also allows you to fetch a data even from real time from so for example, if it's a flight data which is available and provided by a particular server, I can even directly fetch from directly from a web server as well. Or I can even assume that I have already a big data with me, which is actually already cleansed and it is ready for for analytics purpose. Then what I can do is even I can use that big data as well as an input. Or I can even use a simple SQL server or an Oracle or whatever, maybe a DB. Or in the least, you can go for building a CSV. For example, you have all the raw data as a CSV. Use that as data as a CSV as an input and then start processing that as well, right? So those are something which in the you need to take the data and then train the data, and then finally you have to process the data, right? So once you process that, that becomes as a final model to give it as an input for the predictive analysis, which machine learning takes care of it. And all this thing, and finally, once you have a predictive analysis and you found that this is the final report you have, actually, this is the data which you have, you need to also expose it to your apps, right? Finally, what is the purpose of this analytics? This analytics data should be viewable in app. For example, my CEO might will have an app. The app, he might have a dashboard where he want to see this. Probably in a launcher screen, he want to see a small notes coming in. Okay, in next 2 days, actually the price hike maybe go for for this particular apparel, or this price hike may go for a petrol or a diesel. So this data or maybe a chart or something is finally the output, right? This is something which how we can achieve it. Once you build the whole machine learning, the final thing what we can do is we can also publish this as a web service. So once you publish a web service, web service we all know pretty well know, we need an input port, we need an output port. So for the input port, you need to say actually what is the input for the web service, and what is finally I'm going to get is the response. So there is a request and a response to it. So web service, you need to set up an input and output, and finally you have an API in place. Host the API, consume the API in your application, you get the predictive analysis report in your application, any application you built it. It could be your enterprise application, or it could be your mobile application, or it could be any of your other web applications as well as through online which you built it. That's how all the entire, even any business which are running nowadays through, even if it's a simple, small scale industry to a large scale industries, everyone wants this predictive analysis to be in place. It could be a Flipkart, it could be a Myntra, it could be a Snapdeal, it could be a even a simple Swigger which does a food purchase online, or it could be even for a McD, or it could be for a Pizza Hut as well. So they wanted to. That's how they set their business. For example, if it's a Wednesday sale where I get a buy one get one, it's actually a predictive analysis which is going to cost that, right? So for example, the last 3 days, you know what happened in Karnataka, right? So we had a Bandh in place, and and which has really made the cab service to be increased their tariffs more. Because the people don't have any other chances. So this they would have already predicted, or else they would have not able to suddenly on Monday they cannot hire 100 more cabs and run it on the roads. Actually, they would have planned even a week before when it has been known that there is a crisis is going to be. So when there is a seventh pay commission came out from central, so they are already predicted about saying, okay, that definitely it's going to impact on state and it's going to impact on various departments. If it is impacting on this particular department, what will be the impact actually? For example, in case of transport department. So in transport department, what is the impact? The impact is going to be the people not able to commit. If they are not able to commit, what is going to be the next choice? They have to go with either work from home. The company would have decided for work from home, or they have to go for the using actually their private cab services actually, right? So this all would have been already predicted by Ola, or it could be any other cab service, or Meru, or anyone would have already predicted and decided, okay, let's run for next 3 days, or probably from Monday onwards, we have 1,000 more cars on the roads. And we'll have a sufficient drivers in place, and make sure my business goes, and we can able to make out the money revenue out of that actually that particular situation. So this is what are the overall as a predictive analysis, which I need to be done in at least in an upfront to know that I can run my successful business in place, right? So that is the overall objective of a predictive solution. And Azure machine learning, what all I have explained so far, it's right from getting a data, processing a data, pre-processing a data, creating a model out of it, and then creating a predictive analysis out of it, and then finally exposing it as a web service and deploying it as a web service. This is all I'm going to do without writing one single line of code. That's the beauty about this machine learning studio. So this is definitely sounds everyone, even if it is not sounds very good for a developer, if it is, but it sounds good for basically for a business person, for a management. Because I can do a predictive analysis just by, without even writing a code, I have to just go ahead and build. I need to only have the basic knowledge and sense of, what is predictive analysis and what kind of report I finally wanted to run my business. So according to my business, I can plan and I can get this done, which is what machine learning is going to, Azure machine learning is going to offer for you, right? So with that note, I'll quickly show the, okay, before I get into the demo part of it, just so this I divided into two parts of it. One is the traditional way. We are not doing generally a business analytics. Business analytics will be divided into two things. One is what happened. Right? It's something which I would like to understand, which is the descriptive analysis, right? So if you would have something went wrong, I want to understand that, so I would like to analyze that, which is basically, or what would have went good. So then, which we generally call it as a descriptive analytics, right? Which is more or less, in a sprint model, you do a sprint retro to understand actually what went wrong and what went right, right? So this is what basically a descriptive analysis, right? And then why did it happen? If there is an issue happened, and if it is successful, why it was successful, or it is failed, why it is failed actually. So that is something called diagnostic analytics, because you had a problem. Generally, usually people used to go for diagnostic analytics in a small scale industries in very detail, only in case of failure. In a business, in a larger organizations or larger businesses, they want to really diagnose actually the situation. If they don't predict, for example, they would have had kind of a situation where a product they would have launched, they would have not. For example, it's a simple a phone, right? For example, iPhone, they would have the SE version of it. They would have predicted, okay, probably this could be a successful version of it because it's very slim and sleek. But when really what actual story was the different story, because Samsung was in the other side of it, Samsung planned for other different models to be available in place, and also the small time players like G5 and other phone models actually also come up with some sleek phones actually in the same time, and people really was not impressive actually on sales perspective for the iPhone SE. So that is then that have done actually a diagnostic analysis to find out what really went wrong. The really went wrong is actually, is it because of the production which we did, or is the manufacturing fault, or it's because of the people's interest, or it's because of the competitors actually across, right? So these are all something which I want to do as part of the diagnostic analytics, right? When it comes to now what we are into is, we are into advanced analytics. People want to go for a little bit further. They want to understand what will happen. I don't want to worry about what went in the past, but now I want to focus what will happen actually in the future, right? So even very simple actually. When my wife asks me, every other day in the morning actually to check and find out, whether there will be rain in the evening 3 o'clock, because I have to go and pick the kids from the school, or I have to go and take the cloths before it gets wet. So that's actually a kind of thought process people what you're into and business is into. So that's something which predictive analytics can do that. For that, I need the data. So if the rain was there in the previous day, then obviously I have to take that as an input, and then think about actually the other factors such as weather forecasting data, and then come up with the predictive analysis. Yes, there will be a rain in this. So same thing for if a traffic congestion can happen in a road, for example in a Marathali bridge. So of course it's not for Marathali bridge. It's always probably we'd go for a different location on the road. So there I have to be predictive. Okay, because it can be traffic congestion on that area because there is some political party is going to do some meeting over there, which may cause actually, which is an input for the traffic department actually, so that they can hire some some more, they can deploy some more traffic concept over there to freeze the traffic more, right? Or it could be for identifying the number of mishaps which are happening on the road. So I have to want to predict actually whether this road is fine enough so that I may not have more traffic mishaps on the area. So these are something which I just will do with the predictive analysis. And how can we make it happen? So once I have the predictive analytics in place, which I know what will happen, then all I wanted to know is how can I make it happen? So I know this what will happen. So this is going to happen. In this case, if I want to make it actually true, that is what they call prescriptive analysis. So it's like you go to doctor, he says actually, boss, you will have for another 2 days, you will have a cough or you will have a pain, even because you are suffering with some mild fever into it. So that is, then I'm going to prescribe you these things. Please follow for next 2 to 3 days. You will get settled down with this problem. So that's what we basically call it as a prescriptive analysis. So I have a problem in place. I know how to deal with it. So I know how to deal with that problem. So that's why I go for a prescriptive analysis, which is the foresight. Predictive analysis, insight, and this is the foresight part of it, right? And both of the traditional PAs are which are insight on this case, right? So with this note, I'll go for a quick demo of Azure. So guys who are on the link, hope you are on with me. And if you have any questions, probably I would like to take. I'll put a break around by 3:30, and probably after the break when we come, I can give some time, for your questions actually. Okay, I have to log out from this because this is my customer's account, so I'm going to sign out from there. I have my own cloud subscription. Microsoft Azure, people even for startups or for anybody who are interested, to move to cloud and understand how cloud suits for me, how cloud would benefit for me. So in that case, probably what Microsoft is doing is they are giving actually a 180 days trial. Sorry, not 180 days, 28 days of trial version of Azure subscription. I'll give you at the end of the session. I'll give you the link, to go ahead and subscribe for it. It will ask you for a primary details. In fact, earlier it was a little bit complicated. You have to bind your credit card details. But now they have changed both for credit card and debit card, and they also don't do any charges. just for their verification purpose. Actually, they keep it with you. They will charge minimum of 70 rupees after you get the trial version of and you can use it for 28 days. And you can play around with that. You can host it. But the only thing is that you won't get support from Microsoft actually for that. But if you are interested, then you can go for a subscription later. You can buy the actual subscription actually, which is required, and based on whatever the costing model into it. Right? So I have this is my my customer's account. So I'm going to sign out from that. I can't do anything over there. So I'm signing out from there. So I'll. All right. So what Microsoft does is, it gives you Azure and cloud, you buy a subscription. Okay. Now, what can you do with that subscription? How can I go ahead and set up my missions? How can I go ahead and set up my cloud services? How can I do a deployment? For example, how can I do a machine learning into that? So what Microsoft does is Microsoft developed a portal for that. It's basically like a control panel, right? For any applications, there will be a backend, which will be a control panel, right? So like this, they developed a management portal, and they have two versions of the portal. One is with the portal, which is the latest for Azure portal, and there is also old portal. So I'll show you with the old portal, then I'll show you the new portal of that. So when you have a subscription in place, and what you will do is you will be bounded to some particular corporate account, email account, or probably you will be bounded to some of your live account or any other email account as well. So once you get that email account, and the subscription will be assigned to you. So Microsoft will assign the subscription to you. Once you assign, then what you can do is you can actually go into a website which is basically called manage.windowsazure.com. Manage.windowsazure.com is the portal, is the old portal, in fact. So if I get into the manageazure.com, then it will ask me to enter the credentials. So since I have already logged in, so I'm going to log in into that this is tricky. So I think I forgot my password. Hope it works. It doesn't work. Push. Yeah. Okay. So this is I mean, for the people who are new to Azure, so this is the portal, which is basically the Azure management portal, and in fact, actually, it shows me all the information which I have hold. I told you about all the varieties of different services which clouds offers, like as I said, web apps, virtual machines, mobile services, cloud services, batch services, SQL database. So you can also, create your databases in SQL Azure, which is basically the SQL version 2014 version of it is actually, in fact, the latest version, whatever, maybe not 2014, whatever latest version of SQL Server is there, that will be available on the cloud. So which we will also go for a SQL database. And SQL database also offer as part of a platform of services, or you want to install it, you have to buy a infrastructure service and then install there actually the license of it, right? And also Azure provides, apart from the database, it's also provides something called storage. Apart from the RDBMS database model, which we know, it's typically the SQL Server, but they also offer something called storage. Actually, storage are three different models. Actually, there are varieties of storage models. Actually, one of the storage model is actually something called blob. We can actually store the mainly, for example, if you are storing an image, or if you are storing a content, if you are storing a page, or you are storing any binary large object content can be stored as part of the. So there is a storage called blob storage, and there is a storage called table storage. Table storage works like your keypad model. So it typically works like not like a typical row records, kind of model. Of course, it's a rows and records, but it's more of a key pair model actually, right? So then they had table storage as well. It also has queue, and also have cache. So those are all something which available as part of. So we are going to mainly focus on some of the one of the storage, which is basically we need to create a storage account, because when you are building a cloud service or solutions, anything, the runtime data, which is, for example, it could be a configuration, or it could be any runtime data, or any either supportive data or file or something. We need a place to store the data, right? So we need a storage account. So you need, the first thing we generally, as part of the machine learning, is you have to create a storage account actually. So I have already a storage account in place, which is there already. That's what it shows you up the top for the demo purpose. I have a demo WS, storage, my MLS storage, and then I have also a workspace as well, which is a machine learning workspace. So the first thing what we require is basically to create a machine learning workspace. So that's why I have already set up all of them. Anyhow, I'll show you how to basically create this, and I'm going to switch over to another one site from here, which is another one site is basically the Azure Machine Learning Studio. So this is the management portal of the Azure, but I'm going to switch over to another one website, which will be the Azure Machine Learning Studio. But I'll come to the later. So where I will find is, so HD Insight is nothing but the big data, Hadoop and big data. Actually, that's what the HD Insight, which I told you, and media services, all of them is there, and this is what our machine learning is going to. So we have one of the services of machine learning. There are so many services. I would recommend people who are going to be interesting to get into the cloud services and cloud computing model, or you want to even to provide solutions, offer solutions to your customer as well, or you want to recommend to your customers actually about cloud advantages. In fact, so definitely just build your knowledge on the Azure. Please reach out to me. Feel free to reach out to me. I'll give you inputs in terms of that. And of course, we also have a practice in place. So please reach out to me for any such kind of requirements are there actually in terms of the cloud services. So I can give you some sufficient input actually for that. Of course, we have enough very big team as well actually in MTP. I work from MTP location, even though I'm an Harman employee, but I work from MTP location because I was part of Symphony Telecom. So, but we have a huge practice over there actually. A lot of people are over there actually working on cloud and cloud computing model, and which is definitely going to be a very important thing to understand before we even start using some of the services of the cloud, which is, for example, machine learning in this case, right? So then another one is the stream analytics and operational insights. Actually, again, I'll come back to that. Networks and traffic management. So there are varieties of services. In fact, the last one you can see very interesting. You can go for Active Directory as well. So you can even migrate your Active Directory objects actually from your on-premises to cloud. And in fact, Active Directory is provided as a free of cost in the cloud actually. So there is no cost involved into it. So if you have a cloud subscription, you can build actually your own Active Directory over there, and you can move your objects from your local on-premises, or you want to create a trusting between your local on-premises Active Directory and the cloud on Active Directory also. That is also possible actually, because it runs as a service. Active Directory runs as a service actually, right? So those are the few things. And coming to the machine learning part of it. So since I have already a machine learning workspace, because first important thing I require before if I want to build a predictive analysis solution using machine learning, Azure machine learning, I need to have a workspace in place. I need to have a machine learning workspace. That's what the first thing I have to do is I have to create a machine learning workspace. So just for a moment, before I jump in for the other demo, part of the demo, I'd like to also give one more information on that. This we already understood what is a predictive analysis. We talked about it quite a bit along. So basically it uses various statistical techniques which we follow it, and how the statistical techniques are followed. Anyone can give me some inputs? How you generally come up with some statistical techniques when you want to build a predictive analysis? For example, I have a data in place. I trained my model also. So now what? How do I can do a predictive? So there should be some mechanism in place, right, to do a predictive. So how it can be? Because it's a general thought. That's what I'm asking this question. Guys, over on link, can you answer this? Yes. Correct. Right. But what is exactly it's going to provide you? I mean, because you have a sample data in place, but finally you need to you might have your vision in terms of what is your predictive analysis you want to do. You know what is required to be done, right? But for example, if I wanted to achieve actually, as I said, one simple predictive analysis solution, if I said is basically I want to find out the flight delays. So I want to predict that. For that, the data is there, but how do I predict that actually? For tomorrow, it's going to be what are the airports are going to run? Airline carriers are going to be delayed, or which airports are going to get affected. I'm going. That's my final objective. That's my finally I want to see in my dashboard as a report, or maybe a bar chart or something. So for this to build that final response or report in place, I may need a logic in place, right? I need a logic in place because I have only a raw data with me. I have a raw data. I trained that. I made it as a model because model is only the input actually which I can use it for to process that. I need a logic in place. But if I want to, but the logic is something which we derive based on an algorithm, right? As part of your, if you see, as I said, if you want to become a data scientist, as I told you, there is one career which now it's in peak now. Everybody want to hire data scientists, actually very good data scientists. So if you want to become a data scientist, the first thing as an important, a thing which you need to carry with you is basically the to be a very good, problem solver or a solution finder, where it all comes based on your complete, knowledge on the building your. It's not about technical solution, right? It's actually the other way around, actually. So it's about building your algorithm. So what kind of algorithm I have to choose first of all? If I want to come out with this report, first I need to understand what kind of algorithm I have to choose. There are different kinds of algorithm. It could be a linear, it could be two linear, or it could be a binary. There are various kind of algorithms are available, and of course, machine learning also, gives you, offers you a different types of algorithms also to choose yourself. So when you are running a predictive analysis, you are creating a predictive analysis solution. You need to inform to the machine learning. This is the algorithm I want to put in place, right? And how do I put this and how I can I said earlier a word actually that saying you can do all these things, achieve all these things without writing even a single line of code. Is that of course it is of course it's possible, and I mean 200%. You can build such kind of a predictive solutions even without writing a single line of code. It's all about I'm sure people who have worked on building a workflow solutions would know how to visually creating a workflow. All you need to just keep the activities in place and then drag and drop it. How to build your if it is could be a state workflow or it is a sequential workflow. You know how to build it. It could be a same kind of a model. You just going to be visually you're going to design that how your data should be. So you fetch a data. How do I fetch a data typically in an application? I know finally my data should be fetched and put into a data set. If you're a .NET programmer, you know very well that you always play around with data sets, right? So data set is something which you can build. Just it's like it's one of the machine learning artifact. So just you need to drag and drop it, you will get a data set. Then I am sure that in Visual Studio, most of you guys would have done to avoid more of time spent on that actually, writing the code for creating the connection and all those things. I need to set some properties, I'll get the data set. Similar thing, actually, there is an option here. So the same thing, the way it works. So you create a data set and then take the data set. Then what you need to do, for example, based on the data set, I want to split the data. Let's say, for example, so I want to split the data, for example, half to half. For example, I have 1 million record. So you want to split them into half into two different data sets. Then again, what I can do is there is a function and a methodology which is already available. You need to just drag and drop the split one, and then set your property saying, okay, how do you want to split it? Okay, it should be 0.5, which you want to split half of the actual data. Then you can again drag and drop it. So that's how the whole process will work. But still, there are some in occasions, and when you want to have very customized, very very detailed out, predictive solutions you want to when you're building, obviously it requires you to write some few lines of code as well, which is basically, I won't call it as a code, it's basically about scripting. I'm sure most of you in the room heard about another hot language which is on the cart right now, which is called R. Which is called, I'm sure there is one more training is going to happen on R programming. So please attend the training. It will be very helpful actually for this machine learning as well. Machine learning uses R programming. Okay, so you can create actually R scripts. R scripts is something, R language is something. Anyhow, I have a demo as well actually to show that how R works. Actually. But R is something which helps you really on building statistical solutions, statistical programs, and also graphical programs actually. So it's built by two gentlemen actually, which is called Robert Gentleman. In fact, his name itself is Gentleman, Robert Gentleman, and another one is a Rose. So that's why the letter stands for R. Both of them are R's. To start with the letter R. That's why they are called as R. The R programming actually. It's in fact open source as well. That's the reason it was more successful. So that we can use our scripts, and we can actually create our customization, create a bit of programming on that, and then you'll be able to create actually a customized, very detailed predictive analysis solutions as well, right? And moreover, I told about the other part of it. When I say the algorithms, those algorithms are something you don't need to build anything right from scratch. There are ready-to-use algorithms are available over the gallery. I'm going to show you some galleries as well. There is a Cortana Intelligence Gallery available. I'll take you to that website. I'll also show you that gallery available. Cortana Intelligence Gallery, and there is also Azure Marketplace, which is having lot of such algorithms in place. You can choose that algorithm which will be suiting your requirement and just implement it. That's it. It's a drag and drop, more of a drag and drop, and apply that algorithms. Do some small say it's like a configuration. You do it, you're done. I'll show you that as well. And also, this gives you the benefit of you don't need to write anything on building the algorithms and logics of your own. It's already there in place. Just pick that, whatever the algorithms. Only thing is that it's all left to us in terms of choosing the right algorithm. That is a knowledge you need to build it, right? For that, there are a lot of you have to do hands-on. You need to understand how it works. You need to a little bit get into a mode of data scientist. You need to understand how does a data scientist works actually. For that, how do I choose the right algorithm for this kind of a predictive analysis? Those are something which comes in your practice. It cannot happen just like in a day. You have to practice and practice. Obviously, then you will choose a right algorithm for what kind of predictive analysis is required. One or two predictive analysis solutions you build, then you will become a champion of understanding what kind of algorithm will suit for what kind of predictive analysis. So when customer says, hey, I need this, then you will think about, okay, this is the right algorithm I have to choose for this predictive analysis solution actually. I'll show you that as well, right? So that's why the reason I just stopped that demo, I passed the demo. So this is how a basic machine learning workflow, machine learning will work actually, right? So build models from data and operationalization as a machine learning solution. So what we are going to do is, this is what the first part of it, which is the data collection. You need to do data collection. So what could be the data, what could be the format of data, from where I can get the data? The data can be in a blob or it could be a table, which I told you, it's one of the storage type in the Azure, apart from the database. And then we can also use Azure HD Insight, which is nothing but the Hadoop. So you can use the Hadoop. So if you want to use that, or you can use the relational database, which is the Azure SQL database, or you can use the data lake. I'll come to that part. Data lake is one of the other recent trends on utilizing it for the analytics purpose. I'll come back to that. This is a massive data store. How to manage a data lake. So that can be an input for your predictive analysis.
Azure database or any other?
Which one?
Only Azure database or like your premise database also can be?
For this database, huh?
Yeah.
Azure SQL database.
Only Azure, cloud one, not like you need to have some premise.
On-premises data. You have to link it. It's possible still. Usually your cloud and your on-premises can be connected together. There is something called actually you can create an IPsec. You can create an IPsec between your on-premises network and your cloud network. That's how any client, whatever the clients which are working on cloud solutions, all of them never go with only cloud actually, because some of their enterprise data will be on their on-premises. For example, for Toyota, the way which we are working is, Toyota has a huge, because we are doing a telematic solution for them. All of their operational data, like for example, the vehicle data, the customer data, their dealer data, or their pre-sales data, sales data, warranty data, everything is actually available on their enterprise system. And for each of the enterprise system, they have a separate systems available and databases available. So what we do is, we are building a cloud solution which will actually consumed by a mobile app. So we are developing a mobile app. Sooner it will be launched actually for all the Toyota customers. So that mobile app consumes the APIs, which is cloud services which we built in cloud, and the cloud gets the data from the enterprise system. So there is connectivity between the mobile to cloud. It is an internet connectivity. Because we are exposing endpoints of an internet exposed 80 ports and 443 ports exposed to the mobile app actually. The network, I mean the cloud and as well as the Toyota's network are being connected to actually through a IPsec actually. In fact, there is one more thing they are offering in Microsoft Azure, something called Express Route, which is a kind of a dedicated connectivity actually, which gives you the more speed and performance. Mainly, it also gives you the reserved IPs and all those things we can do. So for that, there is something called internally there can be a network which you can also still access the data. Right? Then that data will be fetched, and we use this ML Studio, which I mentioned, the machine learning studio. Anyhow, I show you that portal. And the beauty about this ML Studio is something which you don't need to anything to be installed, or you don't going to invest on something having configured or installed actually in your machine. It's completely through online. So you go online to the ML Studio, build the whole predictive solution over there, right? So that's how the ML Studio is not going to be requiring any offline installation required in your machine. That's the beauty about it actually. And the whole predictive solution and including the web service deployment can be done through this online portal itself, an online website itself. So ML Studio is available as an web app. That's what's called as ML Studio web app actually. It's a web application, right? And then what you do is you build a predictive solution. You need to expose it to your apps, right? So you have different kinds of apps in place. So for example, I have probably my mobile app. I have some I want to expose it to my desktop. I want to expose it to my tablets, So this is the final. This is where I'm going to show the report, the bar chart or report, what I told you, right? So how can ML Studio cannot be directly consumed. The predictive solution is available in a binary form over the ML Studio. What I'm going to do is to giving access to the data. The response should be sent to the respective apps, right? So I'm going to build a web service over here. So building a web service, again, it's not going to give you any, again, you don't need to write any code or something. All you need to do is, after you complete your experiment, we basically call it as an experiment. In machine learning studio, it's called as an experiment. So after you build the experiment, you need to just go ahead and publish as a web service. It's like as good as you go to Visual Studio, you create a ASP.NET Web API project, right click it, publish it, right? If that's all you are going to do here. Only thing you are going to configure is what is my input, what is my output. Again, it's a drag and drop, right? So input is actually will be from where it actually the data should be coming in, and where the output should be going out. Those two configurations you have done, you have published the web service. Now publish is done. What I have to do now, I have to deploy it. So deployment is again one more click of button. You do a deployment of the web service. Done. Your web service is ready now. All you need to do is, once we create a web service, what we do is, we used to do a testing with some sample data in place. You do a test. Ready? You are ready to consume it in your apps. All you need to do is go to your apps. In fact, one more thing they extended in ML Studio is, they also give you the source code, the client source code. You generally, when you build access a REST client, REST Web API, when you want to access the REST Web API, you need to create a REST client code, right? Even you don't need to create a REST client code. What it does is, after you deploy the web service, it will give you three flavors of code base. One is with C#, one is with Perl, and one is with Python. So if you are what kind of client-side code you are going to write it, you are going to consume it, pick that code, consume it. Or if you are writing for example, if I'm writing an iOS application, so then I want to, then you will build your own REST client code, call the API, done. Yes. You can consume it in PowerShell as well. Yes. Right?
Where the model that comes in.
So when you create this when I create this ML Studio, right, when I create an ML, the first thing I have to do is I have to create a data set. So first I have to set up a data set. Again, data is something. So for example, if you are building a predictive solution, there are so many of data are available across the internet right now. I'll show you that actually. So you can pick any of the data sets for your predictive solutions. In fact, people every day they develop some predictive solution and offer that in online. Either it could be for free or it could be for paid. So you can develop a predictive solution with some, but there are so much of data. Or what kind of data you need? For example, you want to build actually the data for as I mentioned, for a flight data. Flight data is available online. It's the real-time live data is available in online. All you need to just pick the live data, process it. Same thing, for example, for any types of industry which is required, there are data are available. In case still that data is not sufficient for you to prepare a predictive solution, because you might be building a very intelligent application, right? For example, you are developing a mobile app. You want to develop a mobile app which is going to give you a predictive analysis about let's say about a flight delay. There is no any app offers you that. No? Then you can actually take the flight data, right, real time available, build the predictive solution, expose it as a web service, develop the app, and consume the API services into that. You build a chart and then show them. Your app will be, something is going to consume that and show that the report actually accordingly. So there are varieties of lots of data are available. So you can pick the data. Once you get the data, then what you do is you need to create an experiment. Because it's an experiment, right? That's what even the icon you saw that, it's like the glass which it used to be in your physics lab, right? So you create an experiment. Once you create the experiment, you have to start with, creating your overall, you have to design your model first of all. So when you create the model, so probably your data might be proper. Your model might be enough for you to generate your predictive analysis. Then all you need to do is just straight away use the model and then create the predictive and choose the algorithm and then finally create the once you are fine with everything. Finally, what you require is the predictive analysis is also going to be a data. It's not going to give you of course it's a data. Finally, the data that is also a processed data, right? Final processed data. Predictive analysis data is there. Take the data, visualize it, and see that whether that data is sufficient for me to generate this report. Then convert that as a web service. Call that in your application. Whatever the columns you want to use that columns and build the chart accordingly. So this is the overall about what will happen. Anyhow, I'll show you in a moment actually about that, right? So guys, what I'm going to do is the next is I'm going to demo that ML Studio. So before that, probably we can take a break. It's exactly 3:45 right now, I think. So we'll take a break and we'll join in another 10 minutes, right? Okay, I'll straight away get into the demo. So what I have to do is, I have already, in fact, a machine learning workspace in place. As I told you, that is the first thing to do it. You need to create a machine learning workspace in place. So I have a machine learning workspace in place. So I'll open up that workspace. So this is how it will happen. When you probably may not be able to understand what exactly you're seeing these options here. So when I create a workspace of a machine learning workspace, so I have three options. One is dashboard, configuration, and the web services. So web services are nothing but the one which we came as an output finally after predictive analysis. Finally, so you can see the list of web services you have. And you can also give access to your friends and who are parallelly working. So if you want to give access to the web services and also them to test it, you can also give the access to them directly from here, which is the manage access option over here, which is available. And then you also can actually have access to the ML Studio from here directly. This is the management portal, Azure management portal. From here you can directly access the ML Studio directly, and you can also manage your web services. These are something which will be available as part of this dashboard. And so this will give me, because I'm running this machine learning workspace. This is also hosted on some particular location on the data center, right? It could be on VM. So I can actually, this gives me an overall view about my computation. So how much my compute power is taken, how much memory is taken, how much my disk in disk write. It's like a perform monitoring, which you do know, performance monitoring. So that's a real time. You will see that whatever in your data center of that respective server where your application is, so this machine learning service is hosted. So this will give you that because the workspace would have created on some server. Because I took a free subscription account, right? So they would have host when you're creating an instance, it will ask you in which data center you want to host this. When I create a machine learning, I'll show you that in a moment right now. So that's why it's showing you that monitoring of your computer. We can configure that also with different configurations of what and all the other things you want to see as part of your monitoring. And this is the access. This is the configuration which you can do as part of the machine learning workspace. One is should I allow or deny access to the workspace? So I can create a workspace. I can create multiple experiments, and I can even ask my friends to my colleagues to be part of that, or I ask my other partners to be part of that workspace to gain the access to the predictive solutions which I built. So in that case, it asks you that. And then, as I mentioned, you need to also have a storage space, because you're uploading a data, you're processing the data, you're creating a model. All these things are happening, no? So, and also there are several settings and configurations you are doing. All those things will be stored as part of this storage, which I created as storage, which I have created as storage. Then you want to do an encryption of this data, so then it also offers you an encryption as well, built-in encryption capability. So these are something which, as part of the configuration, we do. Then, as part of the web services, I have already hosted a web service. So that's what it's showing me web service, and it's showing that endpoint here, which is that there is only one endpoint which is open, which is 80 port number. I'll just run that. I'm just opening that API right now, which I hosted it. So this is my web service which I hosted it, and there is a version into it, and I can directly open this web service also in the studio directly from here. And if I want to add an additional endpoint, let's say for example, you want to access this API. Currently it is hosted on 80. You want to host it on, let's say, HTTPS enabled API. You can actually also add an endpoint actually and make it for install SSL certificate and make an 443. It's accessible over on 443 port number as well. In that case, we can add an endpoint, additional endpoint to the API. So like this, as part of this workspace, so I have already API in place. Okay. So now let me show. See, currently, for example, if you see this, this information on this. So the name and the storage and the status, it's online, and who is the owner, and it's a subscription of free trial because I used a free trial account, and it is hosted on Southeast Asia. So probably in any of the location in Southeast Asia's data center servers. In fact, you can also see this data centers also. There is a website actually called azurespeed.com. So you can go to the azurespeed.com and you can see various data centers which are where the Azure is running and where data centers are available. And you can also, see the speed. You can see the connectivity. All those things you can see. Which is there in as a separate portal right now. So I choose for Southeast Asia because that is where they can host right now the free trial accounts over there. But if you are having a subscription, if you assume that you are in India and you don't want to keep it somewhere else, a data center which is on Southeast Asia, right? Of course, it matters about the network also because there are multiple hops in place, right? If you have in somewhere else in Southeast Asia, for example, in Singapore or somewhere else, then you are obviously there is even though it is internally there is a dedicated network and everything in place, but still there is a multiple hops in place actually, right? So for that, to avoid that, you can, that's why Microsoft come up with data centers even in India also. So they have now their data center in India, which is on 3 places actually right now. So one is in Chennai, and another one is in Mumbai, and another one is in Pune. So we can, for example, when you're creating a machine learning workspace or a virtual machine or a cloud service or something, you can actually always go for your Chennai data center, which is closest to here. And so that's the reason it's showing you that location, right? So what I'll do is I'll go ahead and and create a new machine learning workspace. So here it's asked me what is the workspace name. So I'm going to give this workspace as demo 2. And it asks me where you want to host this machine learning workspace. It needs to be hosted in some server, right? So it's asking me the location. So I'm select this gives you currently only there are 3 options over here: South Central US and Southeast Asia and West Europe. So I can select which is closest to me, which I can go for Southeast Asia, right? Then it asks you give me a storage account. I can create a storage account, or I can choose one of the storage account which I have already. I don't want to now. What I'm going to do is I'm not going to use my existing storage account. Of course, you can reuse it also, the existing storage account also, because it's a vast space. You can use it. But if you want to have a dedicated storage account, then you can go ahead and create a new storage account also. So in this case, you have to give a storage account name. So I'll keep it as demo2 Harman as the storage account name. So I given the storage account name as well. So now I'm ready to go ahead and create an ML workspace now.
Here you do not give the how much storage you need.
No. This as I mentioned, I'm actually creating a machine learning workspace, but you're creating a cloud service. Like for example, this is a cloud service or a virtual machine. So when I create a cloud service, which I told you I can create a cloud service solution. So that time at the time of configuration, you don't need to enter anything. But when you are doing deployment, right? So for example, you can create a Azure, you can create a web application, you can create a web service. And then when you are going for the deployment, right? At the time of deployment, you can give the configuration. You can specify what is my configuration for this machine which is required actually, right? What usually it does is, as part of the cloud services, it manages 2 set of files. One is called CSCFG file, which holds the configuration of the cloud configuration, or your cloud configuration. And another one is it holds actually something called definition of the cloud, which is called CSDEF file. So when you create a cloud solution package from your Visual Studio, usually we use Visual Studio, right? So we create the Visual Studio. When you create a cloud solution package, in fact, there is a dedicated templates are available for creating a Microsoft Azure solutions actually. So when you create a cloud solution, it asks you to create a package. When you create a package, it will prompt for you what kind of configuration you want to use it. Do you want to use it for a dev environment or a UAT environment or a test environment? So if you, for example, for your dev environment, you may need a less configuration. Then you can specify what kind of configuration is required for your dev environment. Then you can create actually for UAT separately. You can create separately for test. You can create separately for. So the typically it looks like this. I'll just show you a quick live code of it so that you will understand what I meant here. Just give me some time. It's just loading in my machine. You may not be seeing that. I'll share it in a moment. Checking more time. Okay, till it loads, I will continue with this. So now we can. So let's go to the machine learning and see whether it is got created. Now you can see it showing count as 2, and the one which we have hosted is also created right now. So now I have demo2 Harman right now, which is the machine learning workspace I have created right now. And if you go to web services, there should not be nothing because I haven't hosted any web service so far, so it should be empty right now. And then configuration, let's live with what way it's current by default available. I'm not going to make any change. And dashboard. Right, so now what it is going to do is I need to now get into, I have now my workspace ready. I have to build my predictive analysis right now. I want to build my solutions actually on top of that. So I need a ML Studio for that, machine learning studio for that. So what I have to do is just click on this open studio. So what it does is it redirects you. You can see the top one. The redirection is happening to Asia Southeast because that's a data center where I have hosted this workspace. And then it goes to azureml.net. It redirects you to that website where it loads the learning studio, which is the studio like it's online machine learning studio over here, where you are going to do all your job of creating the predictive analysis and everything over here. So now we have landed to actually machine learning studio. This is the portal of machine learning studio, right? This is the online portal where you create, develop, and deploy the predictive analysis solutions over here. So you are not going to nowhere going to be out of this website. You are going to stay here only. Now you can see there are various options. I'm not going to focus on all of them right now. Well, the first where I'm standing is right now on the experiments. What are the experiments I have? I have no experiments right now. But I already told you the very important part of any predictive solution building a predictive solution is first you need to have a data in place. So I need a data set. You can see there is an option called data set, right? So I can choose data set over here. Right? So here currently there is no data set I have currently. I don't have any data set currently available, right? So I can just select new and I can select from local file. So what this will do is it will allow me to create a data set out from a existing, for example, what you can do is you can create a CSV file
for
Excel or whatever. So what I'm going to do is for your quick thing, I'm just going to create one simple Excel sheet. Let's say so I'm just in the process of creating an Excel sheet with as a CSV format. So I'll show in a moment if I'm not sharing that screen. So just for this demonstration purpose, I created one CSV in Excel. So I'll show you that CSV in a moment. So this is my Excel sheet. So I have a column called employees and I'm storing some names into it. So just the data, that's the data which I'm taking. So whatever the data, the data you wanted, you add it as part of it. But this is sufficient for me. Right? So I just save this. I save this as CSV file. Okay. So now what I can do is I can go to from local file. Okay, choose a file. So okay, so I have stored here. So I have a CSV file and it's a generic CSV file with a header in place because I have given a header like employee, right? So that's why the header name is and click OK. So what this will do is it will open up a data set and creates a data set out of this CSV file. Okay, so now I have the CSV data set in place right now. Okay, I can go for my experiment right now. So by the way, I have my uh, solution opened. So this is one of my solutions. In fact, I'm showing one of the live solutions which we are building it for Toyota. I mean, okay. So this is for the reason I'm showing this is to give you the understanding about that configuration which we talked about. So what will happen is this is my overall layers. We have several layers, and we are building a web API. We have several web APIs. We are building a web application. All of them are available as part of this. My solution over here. But finally, what I have is what kind of service which I'm going to host. It is actually I'm going to host actually. I have primarily in my dev environment I have 4 different cloud services with me. And 4 of them in all 4 of them, 2 of them is a web, sorry, 3 of them are web role, and 1 is a worker role, which is the last one you have seen, which is a worker role, which is I can tell you that because first of all the naming, and another one is I know it's a worker role. Other than it all depends upon the way how the code has been written for worker role. So what will happen is as part of this is one of my cloud instance in my actually in my cloud. So I have a cloud instance here. So when I go for a deployment here, so there are different configurations I manage it. I told you, a CSCSD file, CSCFG file, and another one is CSDEF file. So you can see there is a CSDEF file, which is the definition, another one is the cloud configuration. So if I open my cloud definition file, right? So here, as part of my definition, I have to configure my VM size here. So this is a web role, right? So as a web role, I want it to be this VM as to be a size as medium. Medium is actually a keyword for basically to indicate it is a A2 machine, right? So this is a A2 machine which I just wanted, and there are, for example, if you need a large, for example, A3 and A4, you need to go for large, extra large. So if you go to Azure portal, here. So Azure VM size. So if you type in here, so you'll see here. So that is what we have is the A series. Microsoft even come up with now A series, D series, and they also have some latest blade servers as well in place, which is. These are the several series they have: A, D, DS, F, FS, G, and GS. These are the several services, several sizes they have, and this is the different configuration you can see. Standard A0, which is actually that is the configuration. See, this is standard A0, and standard A1. This is the A1. So standard A0, you will get actually 1 core CPU processor with actually 768 MB RAM and 20 GB of max size of disk. Same thing for A1, A2. So this can be configured with actually the respective naming conventions actually, which is we use the small, extra small, and also large and extra large. Like that it goes. So these are the different instances you have, and if you want to know what is the pricing which will cost me for this host getting these services, there is a more link in Azure website which is called pricing calculator. You can use the pricing calculator to find out, even for machine learning, how much it's going to cost you, that you can evaluate that cost over there actually, right? So that is what I wanted to just convey. So based on this configuration, so at the time of deployment, I'm going to specify my configuration here, right? So this is for my, for example, this is for my development environment. When I go for my UAT in production, they are large servers. We opted for A8 machines actually. So in that case, we'll change the configuration and do the deployment, so that it creates the virtual. It deploys this machine, deploys this solution in a machine with a configuration of A8 or A6 or A3 or A2 or that kind of. Right?
VM we can create through the portal also. Or
yeah, through portal also you can create it. But once you create the VM, you need to set the what kind of configuration is required also. So this is actually a PaaS solution. What I'm showing you, we built a PaaS solution. It's not an IaaS solution, it's a PaaS solution. So as part of the PaaS solution, the configuration or something we used to give at the runtime. Either you can give through a code, or you can also configure it through PowerShell, or you can go to portal and also do the configuration as well. And change that configuration also at runtime. As I mentioned earlier, the beauty of the cloud is actually there is something called auto scaling, which gives you to span your, increase and scaling, scale out, scale up, scale down according to your load of your application. So if your application requires more load and it comes to know by default there is an intelligence built by based on your memory, based on your CPU, you can automatically configure it to say span it by 2 instances, another 2 instances, so that it will create a load balancer and it have 2 instances. In fact, Microsoft by default, if you are going for a production and they want to support SLA support should be there, they ask you to minimum configure 2 instances. So what we used to do is, as part of our configuration here, when we go for production, in our production configuration, you can see here, it's currently 2, it's 1 actually. We used to increase the count by 2. So at the time of deployment itself, it will create 2 virtual machines and do the deployment. So that your application will be run through a load balancer. Request will go to a public VIP, which is a virtual IP address, and then that VIP will redirect to the respective machine, because the load balance, that is a load balancer. So internally it creates a load balancer for that, and then that load balancer will take care of it. So that is the way how overall it works actually. So now returning back to my demo, where we have the original, what we are supposed to be focusing on. Yeah, so this is the one. Now what I'll do is I'll go to.
We created data set.
Yeah, we created a data set. So I'm going for a new experiment. So I'm in experiment. So once I click experiment, so this is what happens. So this is something which I told you in some time. So there are so many experiments are available online. So for example, if you are starting with a predictive analysis, you may not be knowing where you want to end up actually, but you know what is your result you are expecting, but you don't want to start everything right from the scratch. You want to use some existing experiment which is there in place and then use it as a template, which usually people will like to start with, until you become more expert into it, right? So for that, there are a lot of experiments are available in place here. So all these are whatever you are seeing here. These are all the samples which are already available. In fact, Microsoft gives you a nice little, oops, I got cut off. Guys, you are in the link, you are available?
Yes, Uday, we are.
Oh, okay.
Yeah, Uday.
All right, thank you. So this gives you a lot of experiments and data sets which are already in place. You can see there are several. For example, this is one thing. For example, breast cancer detection. So this is one of the predictive analysis which is already available in place. Customer and relationship prediction. This is something everyone would like to have. CRM is one of the major things. So you can use this. See, this is for direct marketing. So they are using an algorithm of binary classification. This is a binary classification algorithm. Okay, and this is most of the bank will like to have it. So they want to see the credit worth of the individual before offering a loan to him. So we want to see the credit risk of a customer. Basically similar kind of thing. They will use these reports actually, right? So there are various such kind of see, there is a flight delay which I already told you. There is a experiment which is already available, and they are using the algorithm of two-class boosted decision tree. I'll tell you what are the different types of algorithms which are available, so that time you'll understand what are those algorithms all about. So you have to choose this. Okay, but in meanwhile, so you choose this different kind of, either you choose all the different kind of experiments which are available, or there is also one more website which you offers. This one. Closed. Okay, yeah, this is the one. So this is for they did it for Titanic. This contains a Titanic data set, which about that ship actually. So you go to that gallery.cortanaintelligence.com. Okay. So when you go to this website, this is where you will find all the intelligence data which is available in place. So once you land to this website, you click on Browse All. Once you click on Browse All, you choose the Refine It by Experiment. There is also different refinements are there. Machine Learning API also available. But you refine it by experiment, right? So what you do is you click on Browse All, you will see the experiment in place. So once there are, you can see there are several types of experiments are available here, right? So you can choose any one of this experiment. For example, I can say this is one of the experiment which is already available. So this is someone hosted by a third-party person called Raj Iqbal, and these are hosted by Microsoft itself. So there are so many experiments which are available, which the same thing which I just shown you there, but this is the gallery. What I shown you there is actually the same thing which is replicated over there. This is taken from this gallery, right? So for example, for this was retail. So for example, flight delay prediction. So you can select this experiment.
All these are in Azure?
Huh?
All these are done in Azure?
Yeah, all of them are in Azure. All of these experiments are in Azure. So these are Azure ML experiments only. So what you have to do is, once you see that the algorithm which is in place is used for this, basically the summary of this experiment is, this is to predict whether scheduled passenger flight is delayed or not using a binary classifier algorithm. This is using a binary classifier algorithm. So this is how the prediction is happening, and when you go to the flight airport, what you are seeing is actually also based on that. So there is a flight delay prediction which is happening. So what they do as part of this flight delay prediction is, so they use an historical on-time performance and weather data, both of them, on-time performance plus the weather data, both of them they take it and predict it, and predict whether the arrival of a scheduled passenger will delay more than the 15 minutes. So basically there will be for every individual airport, every individual airlines. So you can take this data, and then the individual data will have, what will be the usually used to be the delay. For example, some will be on minus, some will be on plus, where minus indicates actually how many minutes it was delayed, and the plus indicates actually how early the flight was also. So those informations we can, but this is mainly through prediction. What are the flights may delay more than 15 minutes? Because that 15 minutes delay is actually the benchmark for it, for the flight arrival. So then what we do is we can directly open this open in the studio. So when I click open in studio, it opens me in an ML studio. You can see here, it will open. It's currently opening. It's opening. And it's asking me because it's as I told you, that's a experiment which is already available in place. We want to replicate that experiment to our workspace, right? So that's what it's asking you. Do you want to copy experiment from the gallery? I have that experiment already. And to which workspace? I have two workspaces. That's what it's asking, which workspace you want it. And click OK. So this will create me a template of an experiment out of it. So if you straight away, what you can do is you can take this experiment, create a web service out of it, and build an application and develop an app, and provide the online, flight predictive analysis for 15 minutes delay flights.
But we need data set.
This all is already there. See, it's over. Everything is done. This complete experiment includes the data, model trained, pre-processed. Data pre-processed, model trained, analyzed, and also applied the algorithm. Final response is also in place. So the outcome of this particular predictive solution is going to give you the flights which are going to be delayed. Each airport wise, it's going to give each airlines wise, it's going to categorize it. It's going to give you the delay of the flights actually, which are more than 15 minutes actually. That's the final. So what you are seeing right now is actually the top one is nothing but the heading of this experiment, and don't worry about what you're seeing on the left hand side of it. I'll come back to that later. But this one, probably if it's smaller one, you can increase it. So it's too much. Okay. All right. So that is so I'll take it one by one. So this is my data. What is the data is flight delays data. Okay. From where it is coming in. Okay. So the data is there. So I expand this, for some reason it's not working. Anyhow, I'll visualize and see. So what I'm doing is now I'm visualizing the data which is there in the data set. So if you see that this is a raw flight delays data which I got it. Okay, I'm trying to check it from the location. Actually, it is taken from a live URL, flight delays URL. Anyhow, for some reason it's not opening. I'll show you that in a moment. So what is showing us? This is the different years. These are the past data, right? So this is the different years. So right from 2013, you know. So then day of month, day of week, carrier. This is the airline carrier, which this column is the airline carrier. So you can see here. This shows the nice little beautiful histogram as well about that individual carrier wise. Then origin airport ID. Okay, and the destination airport ID. So again, airport IDs, how do we map it to the respective airport names? I'll get you I'll explain you how to do that. Then CRS departure time and departure delay. Departure delay is giving actually there is a -3. So there is actually I think this flight has reached actually in -3 means in 18 minutes actually, because it's a 15 minutes delay we are expecting. So there is a from the expected delay it is actually gone for -3, right? Departure delay, and then this is same thing for arrival delay, right? So and what are the cancelled flights as well? So this gives you the numbers actually over, right? So this is my actual data, and there are close to 2 million records over there, which is also there with the 14 columns into it. So this is my input data for this predictive analysis of flight delays which are more than 15 minutes. So this is the data which I'm going to take in. From this data, I'm going to predict actually the flight delays for now. Now what happens is, now I have the data. Now what kind of columns I need to fetch from the data? That is the next part of it which I need to do. So that is what if you see here, there is one more, another one entity which is actually an experiment item, which I have something called select columns in data set, right? So when I select column in data set, it already shows all columns, exclude column names, this. How I did that is, this data set is already connected from here to here, right? So for example, so there is no data, that's why that red color mark is appearing now, right? If I run this now, if I play this now experiment, it will fail because there is no input here for the next level. So what I have to do is I take this data. I'm showing you how we are connecting. So now the data has been given input to for this particular experiment item. So I have this one, launch column selector. So what it is doing is it's actually taken from that data set which we given as an input. It's taken actually all columns, no columns. So it's begin with all columns, exclude. There are different varieties of classes over here. I mean operators which you can use, which is include and exclude. So I can use exclude. I need all the columns, but only exclude these columns. So go to column. How I want to exclude it? Based on the column name, based on the index, or based on the type. So I want based on column names. So I click it here. So it will show me the drop down list. So from that data set, it has flowed in all these columns to here. So I pick which column I don't want it actually. So then, so now I taken it. Then I have to do is I have to convert that categorize those data. That is something called another one model, which another one experiment item, which we use something called edit metadata. Right. So this will categorize it. So how I want to categorize it based on the carrier, original airport ID, origin airport ID, departure airport ID. So based on this, I want to categorize it. So when I see the report in my bar chart, I want to see what are the flights from where it has departure, where it has actually arrived actually. So this is what I want to categorize it, right? So that's what I categorized it based on make categorical. That's what there is an option called make categorical. So this is edit metadata will give me make it categorical or non-categorical actually. So I have to set it for make as in categorical. Then once I done, then I wanted to probably based on this data, what I have to do in the next level is now I have categorized it. So I am able to categorize it. What I have to do, based on the data which I have, I want to round down the scheduled departure time to the full level. Because if you see the scheduled departure time, the original column here, original data, I click on visualize it. Take it to the live, that's why it's taking some time.
Yeah, it is something looks like ETL work.
Yeah, more of it. It's not a complete data. We are not doing a complete data mining over here, but we are taking the data and pre-processing. What we are doing is pre-processing. I'm doing pre. I would have directly used the data, but I found some I want this data to be this way. Then only it will be suitable for me for getting my actual report. So I'm pre-processing now the data. This is all. This is the step. Whatever the select columns in data set, edit metadata, apply mathematical operation. These are all my pre-processing part of it. So I'm doing a pre-processing. I don't know what the hell is happening. It's some reason it's taking time.
We are rounding up that time.
Yes, rounding up. So the rounding can be done with one more. There is a function which is available. Just you need to drag and drop it and make it as an apply math operation. So when I apply, click them. Let me refresh it. It's very, very interesting actually once you start understanding the benefit of the ML Studio, because the predictive analysis is something we would have saw that you have a basic idea about understanding about the data scientist and the analytics actually. So with that, carrying that knowledge and building such kind of a predictive solution using ML Studio is awesome, because it gives you such kind of a flawless way to build this without writing one single line of code. It's all about your knowledge, how to chart out that it's like preparing that and finally coming to the algorithm as well. So let me do one thing. I'll go back to this one and see. I can also visualize from here. Okay, I have to run this once. So I'll run it once because this is not a run. This experiment is not a run. So if I have to run this once, then only I can see in the next levels this data is getting processed. So I'll run this once. I'll have to run this. I have to just click run. So what it does is it processes this whole whatever that predictive analysis for that whatever I have built my experiment. It runs this experiment actually. Now you can see there is some icons will start appearing. Some green color icons will tick mark will start appearing on each of those the items which you are seeing here. So here it's now processing this one. It's getting to the next level where it's doing select columns in data set now. Forget about this, I'll come to the later. Parallelly, we are processing two set of different data. One is weather data, flight data. And so you can see that weather data is already processed actually. Okay. So now it is processing the flight data over there. In the top, you can see it shows running. That indicates actually still the experiment isn't running and processing. It's like, building your solution, like that.
This we can see now that the dashboard, right?
Yeah. Yes. So now it's that is also completed. So this have to complete the whole thing. Have to complete now. Yeah, but if I click here now, yeah, now you can see it's showing visualize now. Because earlier it was not showing visualize now, because the data was not processed by this particular next level of processing. Data pre-processing is not completed. Now if I click visualize, because what we did in select columns in data set, we picked actually exclude the column names for these things, right? We mentioned it. So then if you click visualize from this level, you can see now, it has excluded all the columns from that first level of data. Now I pre-processed the data so that I get only this set of data. I had already 16 columns, I believe, 23 columns or 15 columns, 14 columns, sorry. So in that I have removed that, and I have only 9 columns right now, which I have month, day of month, carrier, and this origin airport ID and destination airport ID, those information. Right. So this is how this process, and if as part of this data, scheduled time of departure is something which you want to wish. Scheduled time of departure. So if you take this data, so unique value, standard deviation, minimum and max, there's a mean into it.
This time again, the projected in.
Yes. So I have to convert this into the respective full-time hour actually, right?
Yeah, it's nothing but 11 o'clock and 8:37 a.m.
So here, you see this what it is in this experiment this process which we are pre-process what we are doing is round down the scheduled departure time to the full hour. So now if you visualize here, so now we have this 8:37, yeah, right? So this is now processed because of that other operation which we have performed actually, which is the apply math operation, right? So this is an experiment. So then again, if you see again the further what I want to do, I found is that based on the data, again there is an round down scheduled for departure time full hour. Okay. Then what I'm doing is, since I got this data finally, so I'm doing actually in the parallelly I'm processing also the weather forecasting data as well. So weather forecasting data is something which I have again here, which if you visualize what we have in the weather forecasting data. So I have airport ID, which based on the forecasting data. I have airport ID, year, month, date, time, and sky condition, and there are several other data as part of it. Visibility, weather type, all this information with regards to my weather is available as part of this, right? So I take this weather data, and then here this weather data, what they are doing is for wherever there is a missing value. So they are sitting there. What they are doing is here that weather data set which has been uploaded is actually is a raw data. So they want to convert it as a data set here. And if there is a missing values for wherever in any of the column, if there is any missing values, they want to replace it with the M actually. I think we'll understand going forward in terms of why this M is used actually, why they are replacing it with the M here. Then they are selecting the column also here. So in this columns, what and all the column is required from the weather forecast data. So once this all is completed, then I'm cleaning the missing data also. So I have to clean wherever the missing data is available. So I'll clean it up. So what it's cleaning is it's actually removing the entire row. When I find the minimum missing value is 0, maximum missing value can be 1. So if the missing value is between this range, either 0 or minimum of 0 or 1, then what I do is I'll remove the entire row because it's not useful for me for my prediction, right? So still it's fun. Then that cleaning missing data is being actually given input for this R script to process it further. So if you see what we are doing in the R script is, this is what it is. This is the R script actually, right? In the R script, I have a input port, which is coming from the previous model here. I mean, previous data cleaning. Pre-processing which I have done, where for the select columns insert. So I'm connecting that input port actually to this cleaning miss data. Then cleaning miss data is giving that input to the execute R script. So execute R script is mapping to an input port. So I'm from that data set one. Data set one is the first data set which I have, and then mam1.mam input port 1 is actually the indication of which input port I am taking the data. And then what I want is I'm going to take the year, month, and day from the data set. Okay. Now they are calculating actually the full date out of that. Using that R script, actually we are calculating the full date and then calculating the adjusted date, adjusted month, and our airport ID, weather. And then what is happening is it's outputting that as finally as one more data set. So it processes all this data, whatever given taken as an input. The R script, converts that as an adjusted date, adjusted month, and adjusted year out of that. Then finally, once this data is available, it outputs it. That output is actually, this is what the output it is, right? So this output data is now my input for my, now I have the airport data also with me, which is all the flights and their times of delay and all those things. Now I have the further forecasting data also. Now what I will do is I'm going to join the data here. That is what this join data will do it. So what are the data? I am taking it from the join key columns from L and join key columns from right, L and R, right, from the left side and the right side actually, right? So what are the columns I'm selecting from there? What are the columns I'm selecting from this data set? So it takes both of the data from both of the data sets, because I need to merge, right? I have to join them, the data. So that's what I'm selecting these columns from that data set and this set of columns from the right data set actually. So once it is done, then I'm selecting what kind of join type I require. I couldn't edit it because it's still running. So, so it usually in your SQL operation, which you do an inner join and outer join or left join and right join. So same thing, you can also select the inner join type here. So it's an inner join here actually. Okay. And there is also option to keep right key columns and join the table if you want. Actually, usually we used to do it, right? So then you have the join data with you. Then what here in this join data, what they're doing is, so I think that is a duplication of it. It's not required again there. Now, so that you don't forget it. So there is now we joined airport data and weather data to the relevant records actually. So now we have joined it now. Now they are splitting it. So I want to split that data. So this is actually their analysis, because we whatever the way which I wanted to take my report output. So that's why I wanted to plan my accordingly how my data is required. So what they are doing is actually split data and splitting mode. How there are several types of splitting modes. Yes. So we have a month which is less than 10. So we're out because we have the month which is adjusted months are available. So we are taking months which are less than 10, which is inclusive of from January till October actually. It's not till October, till September, right? So those data they are taking it actually and then processing it finally. There are several other things which is actually happening. I still is processing, it's not showing up. So once this is all completed, so now we have to finally they have the final process of we have to create this as a respective model. But before applying a respective model, so I'm going to apply the algorithm. So the algorithm which they have applied here is actually the two-class logistic regression for that this data. This is a type of algorithm which they have based on that join data. They are applying this algorithm. And anyhow, it will need some time to explain that algorithms. But you understand that is an algorithm is applied over here. Then once the algorithm is applied, actually, then they are evaluating that model, because that based on the data which we are able to create a model, and then also scoring is actually scoring a model is on as you have the model in place, which has been combined data of both airport and weather data. So that data needs to be scored with respective validations which you want to do. If you want to do any validations on top of the data, those all validations we can apply as part of the score model. And finally, we can evaluate that model, whether that model is enough for me, whether that model can help me to create the based on the algorithm which I chosen, whether it can give me the predictive analysis based on that. So we have to based on the algorithm which I have applied, which is in case of this as a two-way classic regression. So it performs that, and finally this once the evaluation is completed, we have the final airport codes of final data set, which will tell me the list of airports which are actually flights actually which will be delayed airport wise. So now this everything is ready now. So what now still it is not completed, but anyhow I'll stop this in between.
Can you show any of the model?
Sorry?
Any one of them?
Yeah, sure. So now if I have the models, I mean the experiment ready, and it is also already processed, and also we have played already the experiment, it's ready now. Then what we can do is we can go for setting up this as a web service. Right. So when I set up a web service, anyhow it cannot be done right now because still actually the processing is not completed. So what I will do is now I'll stop this experiment and I'll go to my our one of our experiment which we created already. So this experiment is already there. So I'll create a new experiment. I'll make it as a blank experiment. Okay, so this is what you will end up with finally, right? So when you are ready with your experiments, actually, so this is what the final list of I mean the place where you end up with your experiment right up here. Okay, so now you remember actually I have uploaded a CSV dataset which is already available. So I can click here and search for it. Yeah, is there, right? So I can select this. Right. So I have the CSV data. So I have downloaded and dragged it and kept it. So I can visualize it and check. So this is what I found I stored in my Excel sheet right there in the CSV file. So it's showing you the data over here. So we have a column called employees, right? So it's showing the histogram as well as placement. Okay. So now what I wanted to do is based on this, I wanted to probably using these names. I just want I'm just putting a very simple model in place for to just take this data and process it with some data, which is, for example, based on this username, I want to give a welcome to him. So that's actually the input data for me, and which I'm going to process it based on that. So what I need to do is I need a execute R script. So this will give me either I can use a Python script as I mentioned, or you can use your R script also. So I'm using R script here. So R script, what it will do is it will have 3 different ports. You can see there are 3 different ports are here, right? So this port, which is the dataset port, and this is the dataset 2 port, and this is for the dataset script bundle. What will happen is if you have 2 set of datasets which are given as an input for the R scripts as an input. So you want to bundle that as a zip file. It can also bundle that as a zip file. So in that case, actually, you can, instead of giving it as a 2 different data sets, you can give it as a zip file. So you can create a if you have a zip file as an input data, then you directly connect to this port. So it will take the zip file, extract the zip file, and then process the data. So that is why we have the 3rd port number, and it also, as part of the third on the output, it also gives you the result of the data set. And here this is one for the device, for the R devices actually. I'll explain you what is R device later, but the actual response will come from this result data set only. So now what I can do is, this is since my first data set here, so I can connect this data set to here.
If there is more than data set,
that's what I said, the bundle. You create bundle. So that's what 2 data sets you can connect, or if you have multiple data sets, then you can use it. Or what we can also do is, you can create separate blocks also. Like for example, I can create one more data set and then have one more separate execute R script for that. Like we shown that in the flight, flight and weather data. So you can create two different data sets there and then pass it to the execute R script here. Okay, so now the R script is already available here. So this is the default scripting. So I'm not going to make use of this. I wanted only the first data set, right? So I'll remove this code. This is creating a plot out of it, so no want that. So I'll remove that. In the interest of time. So I have a script which I just for this demo purpose I have created. So I'll just take this script. So I'll refresh it here. So I want to give a, as I mentioned, for our script, there is a nice little session is coming up. So please try to attend that, and then if you want to understand our script, actually, it's a very good, it's not very complicated. You can quickly understand the syntax and semantics and everything. So what all I'm trying to do is, from that data set which I received as an input from the input port number 1, I take that input port number 1 data which is coming from employee DB data set, and then what I'm doing is I'm setting a response out of it. The response is I need to have a concatenation with actually the string welcome and the data which I got it from the data set. Okay, so my data set column name is, so I'll remove this employee, right? And then I have concatenating with the exclamatory mark. That's why you're seeing that exclamatory mark, nothing. So paste 0 is actually that function which takes care of it. It's like a concatenation function which you use it, right? So I have this one, and it creates a data frame out of it, which is basically the final data which I want to finally generate out of it. That's my response, and creates a data set out of it. So data.set will give me the final output of what I want to do. So now my script is ready now.
That is keyword, MAML, or we can change.
No, it's a keyword actually. Keyword. Yeah, it's a keyword. For the to indicate the mapping, I'm mapping to another one, dataset model to get that input from that particular respective port number. So as part of your R script language, if you're programming and knowledge, you will understand all these scripts actually. It's not a big deal. So now I'm ready with that. So I can save this. So now I saved it. I can run this now. If there is any error, it will show me if I have any error in that code. So now I have a data set and I have performed actually in response. Now what I can do is you right click this, visualize, right? So the R script, what it did is it taken the data from that input port number 1. Input port number 1 is read and data is loaded. Now I wrote actually a script, line of script to concatenate that and process it. So in your R script, with this, this I just made it for a simple understanding purpose. I made it. Whatever you want to do, any statistical calculation, like I shown in the flight data, what they're doing adjusting of the date and month. Whatever you want to do it, just do it all there, process it and keep it and send it as a response back. The data set, after you get the frame data, so you have to send it as a response from the output port. So input port, you got the input data, processed it with the help of R script, and then you are sending the response data. Whatever the output of that data, you are sending as an output actually. It's like, simple in your normal C# code, which you write as a read line and then finally ends with the, a write line code, right? So that's why we are doing in the map output port also, input port and output port, that we are doing. So now I have this, response in place. So now what I'm going to do is I wanted to expose this as a web service, so that, anyone, feeds the input, gives the input data as name, which is based on the data set which I have. It's going to combine the data and then give that exact welcome message for that employee, right? So now, so whenever a user logs in, let's say this can be useful for a welcome app in your app. When someone logs in, your logging in input will go to this data set, to this experiment. You use this experiment, to pass this logged in username and then get the welcome message built out of it and get the response as a welcome message and show it in your app actually in some of the corner actually. So that's what probably you can visualize how it looking like. So now I'm ready with everything. So now I can go ahead and set up a web service. So I want to expose this as an API, right? Then only I can pass this as input. So then what I can do is, So I have to always, I did nothing, right? I just gone and clicked the setup as a web service project. So what it is doing, now you have ability to add or change the remove input outputs in Excel. So by default it's given me. So I'm not going to worry about this message text, remove it. So the web service input, is from the execute, because already employees db.csv has been receiving that input actually by the execute R script experiment item. So it knows it from where the data needs to come. Then the web service input is something which I'm providing as an input. So then the input reaches over there. So it either takes from the DB or from the input which I'm providing, right? In any case, it will work, right? So then what I'm doing is I need to get the response. But the response is something it is connected to device. But I am not exposing now to the R device. So what I will do is I'll click this and delete it. Now I will create the connection in this, right? Because the response of the results of this is mapped to map output port 1 as per your script, right? You are not putting it to device. So your response is sent to map output port data.set. So it's coming as part of this data set, right? So that's what I'm not taking from the device. So now web service output is also ready now. So now let me save these changes. So it's saved. Now I can go ahead and run once because before I go ahead and deploy the web service, I need to run once the experiment, because I have now added web service input and output, right? There are in the experiment there is a change, right? I have added web service input and output into it, so I have to run this web service once. But see, in the whole process, I never, apart from that R script 2 or 3 lines of code, I haven't written anything else. So it's finished running. So now what I can do is I can go to deploy web service. So there are classic web service, which is the old one, which is a little bit earlier model, and there is a new web service model as well. So I'm taking a classic web service itself, or you can choose a new web service also, right? So which is a new web service model. So I'll select new itself, which to deploy this. So you can see it's creating one more, it's hosting this into a deployment into another website called services.azure.ml.net. The web services are getting deployed now, what we developed now.
And then you can configure where you want to.
Yes, you can see the final response output. What will happen is it is hosting a website now. It's preparing for a deployment now. It's hosting a website now for you. It hosts a web service for you in the Azure Machine Learning Web Services. Okay. So now what's happening is it's created a web service. Okay, and created this, and it given a web service name. You can change the web service name. Then you can also set up an price plan for this. So I will select the price plan. If it is already a part of your, so if you want to offer it for free, then you can mention it for offer it for free. Then I'm just I'll also change this name. Right, so deploy it. So your web service, you mentioned it is a free web service. You are going to host it for free web service, and then you can also mention, or if you want to host this in a S1 with computing include of 25, or if you want to include for compute for 500. So in this case, this charges will be applicable, right? So I want to go with the free version of it. So that's why I want for free. Free will not get any support. That's the only differences. In other case, and another one is it will take its own configuration, some default configuration. This means you will get at least some standard configuration over here. Okay. So now this is ready. Okay, so now you can see the web service is ready now, right? But it's failed. Why it's failed? Meanwhile, I'll go and also create this, deploy this in as a classic web service also. Let me show. This is the classic one. That's a new one, which will, as I showed you. Anyhow, let's see till it is completed. But by the time I'll complete this. So if you see here, so it's created an API, okay, and this is the API help page, okay, and this is the API key. You can click tester, and so it's asking me enter the data to predict actually. So I'll enter, let's say Jordan, right? So it is testing that. You can see in the bottom. You can see that message at the bottom here. So your test is successful. That means it's getting into the experiment, passing this data, verifying whether this data is available, and then it's doing the prediction and giving the response back to us. Now the API is ready for us. So you can, what you can do is you can actually, it also provides you this request and response here. Meanwhile, let me check. Okay. So what it has given us, this is the request. So this is where your API is available. That is the request URI for your API. Okay, so you need to just take this URI, put into a Postman or something, or maybe a Fiddler also. Check this API will work for you directly. Okay, so what is required as an input for this? What is the request header I have to pass? I have to pass the authorization. Okay, content length, all those things. Then I get the response. Then do we have anything? Content and content length and request body. I have to send this way. Response I'll get this way, right? So then I have the C# code also in place. Right? So what I will do is I'll take this sample code. Okay, we'll go to Visual Studio. So I'm taking a simple console application. I'll just press something, I don't know what. Okay. So I'll create this console application. Replace this code. Okay, so what I have to do is already API URL is there. API key, it says ABC123, right? So this I have to go back to my hotel, and my API key should be here. So this is my API key. Copy it to access the API and replace it here. Yeah. So now it is replaced.
Program again copy.
Oh, copy twice. Huh? So and now, so I have a parallel task here, which is in the background. Value. So I'll replace this values. Okay. So now let me go ahead and run this. Sure. I'm almost done actually. That's okay. Score request is failed. Okay, I think there is some issue. Anyhow, I'll take it up as we are running out of time. It's just about the same thing. You know, you have to just the same client code actually. It's a simple REST client code actually. So I'll see what is that issue on that. But otherwise, you know, we can also test it directly. You know, from this by giving to our Postman as well. Okay. So I'm taking a Postman. So it's a post call. So I take this, replace it with my address here. Now I have to add header. So in my header, I have to say bearer. And the API key. Now that's my authorization. I'll take that, and content type should be application JSON of XML. So JSON. And I should also set the accept. So now I have to set up my body. The body is something which I have already. Body. This is my request body, right? So I have to set this. Give only one value. Let's do it later. So that's all. I'm done almost. Control and everything. Okay. So I have to send this. So got the results back. Since I not replaced that next value, no, that was showing well value as it is. So for the one which I replaced the Jordan as an employee name, it has got replaced the value and we got the response. So this is the same, consumption. We have to do it in any of your app which you require, and consume this section. So when you're done with your overall experiment, it takes you hardly 10-15 minutes to create a web service and then convert that as actually a deployment or deployable, and then you can start consuming your web service. So it's the majority of your time involves primarily on planning your data. So that's very important, planning the data. So that is why see, so you have to, there is a various types of data which you need to plan, right? So it could be a wisdom, knowledge, and information and a data. So it's about what kind of type of data you want to take as an input. So data is a raw data which is I got an IP address with read. So then I convert that as an information. I convert that as a knowledge, or I convert that as a wisdom. Finally, to what I have to really do with the data. The do with the data is I better stop the car when I see this, right? So that's the final objective, right? And we do as part of this we do the data mining, which is what in the beginning we have did with the data, and then in that we do this process, where we do a selection, pre-processing, transformation of the data in case if it's a different format or a different way, and data mining and interpretation and evaluation, which is a model. Then what kind of data it is, whether it is a input data is an HTML or it's a PDF or it's a Word or a JSON XML. So what kind of data, you have to select your data type also, and with the different formats which can be supported here. So it can be support, as I mentioned, it can support a local CSV file, or it can support a Hadoop data also which is available, or you can support a SQL database or all those things. Then what you do is with the data is you do a data cleaning, you do filter out of it. Like filtering is something which we did in the select columns, only these columns I require. Then you can do a sorting, saving. Finally, you keep your data everything ready. Then you do a set of data mining tasks which involves anomaly detection or association of a rule learning. What is the dependency for this model? So you have to plan for that. Like for example, weather forecasting data is a dependency for that model for flight data. Then clustering it, classification, those are all, and then finally regression. Regression involves you in terms of actually what kind of algorithm you put in, and finally get the summarization of that, right? So these are the different types of algorithms which machine learning supports. Like if you see a binary classification in Azure ML, we have two-class logistic regression which I which is the algorithm which is applied for flight delay predictive analysis. Then we have, two-class support vector vision. So there are different types of algorithms are available. What you can do is, I'll just show you at the end of my slide actually as well. What type of algorithm is best suits for my predictive analysis, what I'm expecting. There is a cheat sheet available. Microsoft provides a cheat sheet. I'll share you the cheat sheet also, and probably you can use it actually during your deployment machine learning as well. So this is actually how machine learning works. In fact, so it can be a data of any one of this, the green color, and then passes to the ML Studio. Then ML Studio is actually creating an API service and hosting that is in the Azure portal, right? Which is as an ML API service. Then it can be consumed by this enterprise, either by Power BI dashboards or mobile apps, or it could be a web apps also, right? Then I mentioned about the R, which is required for the programming for your mainly for internally used for your statistical analysis and for graphical representation and reporting. R is going to be very helpful. For example, if you draw a graph, export if you want to draw a graph of a linear chart or a bar chart actually. So R programming, gives you that capability to even build that as well, right? And there is a website which you can actually watch out for. It has a very good step by step, for a learner to start with an R programming. Definitely keep an eye on this language. This is definitely going to be a rocking in the future for analytics purpose. Of course, it's already rocking it. That's some. And basics of the important thing to understand for a data infographic is you need to understand the different algorithms which I already told you, and then you have to choose the algorithm, the right algorithm which is required actually. So the infographic algorithms are something which this is. Sorry, I'm taking more time, but just okay. I don't have.
For R, what is the prerequisite? What we should?
So prerequisite for what?
For R, for learning R.
Learning R. I mean, if you are being a Java programmer or a .NET programmer, it doesn't make sense. It's just even if you are a Perl programmer or a Python programmer, anybody can learn this. Because at the end of the day, you are going to make use of a programming language which is going to make your life simple for doing a statistical calculations and analysis, and also for generating graphics and reports, right? So then obviously anybody can actually learn. There is no limitation into that actually of being a particular platform programmer or something. So here, actually I planned for some another 2 more sessions, which is going to be on, depends on the schedule of Harvard University, it will be planned, where I'll be, taking through one of the, taking a predictive model and running through that, which would require again explicit 2-hour sessions of this. So this is actually the infographic, algorithm examples which are available. I'll share you this document also as part of my. So this will, has a different type of say what you need to do. So I want to do a regression on forecasting the future by estimating the relationship between these things. Okay. So for example, estimating a product demand, which will be helpful for somebody like Myntra or Flipkart or Suits. Predicting the sales figures, any industry would like to have it actually, and analyzing the marketing returns out of it. So how much I'm investing on a marketing, because nowadays you heard about digital marketing. So people are investing on that, more of investing on hoardings and all those things. I go for digital marketing. Digital marketing is something in WhatsApp. If I say, hey, this, for example, if the release of a Kabali movie, someone said, Kabali is very good, then obviously that's the change. And Kabali is made successful because of that actually, right? There is no other thing into the movie. It's all about, the marketing trend. They made use of the complete, usage of the data trends which are happening. So everyone who, even though if I'm not interested about, Rajinikanth or Kabali, it's not about that. All I about is someone is saying it's very good. Someone is having a figure of that the pictures of that movie in the flight, and there is a chartered flight which is going from Bangalore to Chennai. This all makes someone, even if I don't have any interest, but it gives what is there. So at least I'll go and see what's the movie. If it's a 5,000 or 2,000, still I'll go. And so that's how they made it. Even within 3 days of able to they're able to reach out 300 crore club actually and beat Sultan. So that's the way how really the reach out is going to do it. So for that you need this kind of marketing, analyze the marketing returns out of it, and then anomaly detection. So this will, if you read through this document, it will give you very all before you plan for your infographic algorithm, which is exactly what you need to do. So if you just go through this document, you will understand what exactly. For example, this is one given for how can you accurately predict demand for your product. So in that case, what all is required. Step 1, step 2, step 3. So just go through this document. You will understand. To be a. This is the first step towards becoming a data scientist, actually, right? So I'll share the document also. Then there are sample experiments which I told you already, which is there in Cortana Intelligence Gallery, which has shown you that. So what you do is you can choose one of the existing experiment like I showed you for flight data. Take an existing experiment, make a template out of it. That's what we did actually. Make a template out of it. Try to rechange that, modify that, and see where if you have some vision, because it's all about innovation and what kind of report you finally want to build, right? So you do all those necessary planning for your predictive analysis, and then make use of the existing experiments and achieve that. Even you can use any of the data which is available, and then you can deploy in the marketplace also, so that somebody can actually consume that and also make it tell you actually whether this predictive analysis is useful for them. So that's the way you can start with sample experiments actually. So when you're doing any predictive solutions, what we have did is uploaded the data, which is what the first step, and then create an experiment out of it. Then train and evaluate the model, which after you create the model, you have to train and evaluate based on the regression which you want to do it. So you can train and evaluate the model and then deploy as a web service and access the web service. So there is one link actually which is available, which is a step-by-step, which will help you to, if you want to achieve one single predictive solution step-by-step. So this link will help you to go step-by-step with the predictive analysis, mainly for for this. I think for flight data itself, it is there. So you can use this link to try yourself. But before that, try to get an Azure trial account. Just type in your Google as Azure trial account, then it will take you through the link to get that Azure subscription actually, right? And for when you create a web service, mainly for creating a web service, you need an experiment. Then you need to set the input and output ports, which we did actually when we set up the web service, and publish your web service. So that is the final thing. And overall, when you before doing this as a web service, the main thing we have to do is we have to do a data science process, which is basically a systematic approach of building your intelligent application. So you have to come with a standard set of ideas and statistical plans and predictive analysis. So all those things you have to collaboratively think through, and that's why if you see that life cycle of that the whole life cycle in that experiment of flight, there are several things they have done. They have taken that, splitted the data, selected the columns, then rounded that data. All these things that's what they want to achieve it, right? So that's the process of data scientist actually, right? So you have those all. Once you planned it, then you can apply it actually. So that is a methodology. You want to plan for a methodology. That's a TDSP, team data science process, which involves about a methodology and a resources to use, how to get this, achieve this, right? This is a whole data lifecycle model, data science lifecycle model. So you create a data, train a data, generate selected features into it, then finally you go ahead and deploy it actually for your what you need to do with that data, existing data, right? So anyhow, I have, as I mentioned, this is a session about to give the coverage of the ML Studio, but on getting into a predictive analysis, I have separate session, which I have already requested Harvard University plan for that. So in that session, I'll explain, give you a hands-on demo. In fact, that's planned for another hands-on demo, so that you can yourself create an predictive analysis and then build yourself and see how it works. But for that, everyone we plan for keeping as a interactive one where everyone will come up with their own idea. So give that idea, and then we can actually create an predictive analysis out of it. Right? So thanks all for being this part of this session. If you want to reach out to me, please reach out to me on mail ID. I'll just do whatever the inputs which I can give from my end. I can share it with you. Thanks once again for everyone. Hey, thanks everyone on the link. So we'll catch up later for our next session actually. I don't have any clue right now, but it is already planned. They have scheduled it since there are so many trainings going on after the integration of Harman. So many trainings are happening. So it's very difficult to get the slots actually.
Need a full day session.
Obviously, how to plan for that only. 2 hours, getting 2 hours is itself is I'm almost last 2 months I'm pushing for them to do this session actually. So I do out of this I do sessions with B.net, which is the Bangalore.net group which is one of the major user group in Bangalore here. So I'm also part of that. So probably if you tag me, I'll also make you part of that if you are not already part of a B.net group. That's one of the majority group which is funded by Microsoft actually in Bangalore. So we meet every month actually twice, not twice, once. And every month there'll be a session. In fact, the next August month session, I'm speaking on AngularJS 2.0 version. And we do a lot of sessions with that, to the community. It's all about for that. What we get it from the community, we give back to the community. That's what we do it. And the benefit also is like, suppose you want to, I'm on the cards right now. It's almost last 4 or 5 years I'm serving the community. But minimum 4 or 5, after 5 years to 6 years, then you'll be also recommended for an Microsoft MVP as well. So you can also get chance to become as an MVP. So so you probably can come out for those sessions as well, where a lot of like Sedge, our professionals meet together just for minded of social cause. So we get together, and Microsoft provides a location it's an Embassy Golf Links only. So we get together there, and they provide the location. They give the projector, the location and room, and in fact. Some snacks as well for the people who are joining. So that's a 4-hour session we usually conduct. So I used to speak there also as part of that this kind of sessions we do it. Okay, thanks once again. Yeah, this will be shared as formally by our Harman University training team. So this all I'm going to hand over to them. So those people will share it with you.
Today, mention some site where you can get the data, right?
Yeah, carry that content.
Autonomous. It is there.
Autonomous.
Is there? It's part of the slide itself. I kept that link.
No, that is the talk about the experiment.
Ah,
I'm just looking for some simple data. Suppose I don't want to use those experiments, I want to create my own experiment. But I'm looking for some data. Those kind of. So like, there's some sites that I know what I.
It is there, but even if you take the sample as galleries which are there in the gallery, the experiments are there. To open that in your studio, then in fact I couldn't open that properly. That's what I want to show that for the flight data from where we are fetching the data. But you can actually open any of these experiments for any type of data you're looking for, and then you can take it from there. Only thing is that those data, whatever the experiment data are, actually they are approved and they have been legally available for our analytics purpose. Other than that, you may not generally usually get all the data freedom.
But those are real data, right?
Yes. Okay, thanks everyone. I'm ending the presentation.
Thanks, Uday.
Thanks, sir.
Yeah, thanks, Uday.